guys, we're going to be working today with angles, and it's two different sections. 1.5 deals with different types of angles, and 2.6 deals with proving theorems about angles. So let's start with some different types of angles. First thing I want to talk about is complementary angles, and you've probably heard of these before. They are two angles, and they have a sum of 90 degrees. And again, key thing is two angles that have a sum of 90. Complementary is again two angles that have a sum of 180. Sorry, I meant supplementary. So that's going to be two big angles that we use all year, and a trick that might help you learn which one is which. If you make a C for complementary and an S for supplementary. Alright, for complementary, what you can do is you can take that C and turn it into a 90. And for supplementary, you can take that S and turn it into a 180. So that maybe might help you learn the difference between complementary and supplementary. Another type of angle are called adjacent angles. Alright, adjacent angles have a common side, a common vertex, and no common interior points, which means these have a common side right here, this ray. They have a common vertex here, but if I pick a point inside angle 1, it's not also inside angle 2. So they have no common interior points. Same thing, if I pick, this is my common side between 3 and 4, my common vertex, but a point inside 3 is not inside 4. So those are adjacent. So let's answer this question. Angle BFD and angle CFD are adjacent angles. Well, let's see if we can find those angles. Here's angle BFD right here. Alright, let me get another color. And let's go with angle CFD. So here is CF, and then there is FD, so there is CFD. So the question is, are these adjacent angles? So I want to know, do they share a common side? Well, yes, they do. They share the ray right here, FD. Do they share a common vertex? They do. They share vertex F. Do they share any common points? So if I put a point inside angle CFD, is it also in angle BFD? Well, it is. So that right there lets me know that no, these are not adjacent angles, because they kind of like they overlap each other. You can say explain. So a point inside angle CFD is also inside angle BFD. Alright, so that's the reason why these guys are not adjacent angles. Another angle pair is called a linear pair, and it's exactly what it sounds like, a linear pair. So key thing here, the word line. They make a line, and they have to be adjacent angles, and basically the non-common sides are opposite rays. So here is our common side. So that means our non-common, this way here and this way here, have to be opposite rays, and in this case they are. So again, they end up making a line. Well, linear pair has a postulate, alright, good word there. And remember, a postulate means that it is something that we believe is true. And your linear pair postulate says if two angles form a linear pair, then they are supplementary, which makes sense. If linear pairs make a line, lines add up to 180, right? Alright, so let's see if we can answer our question here, our algebra question. Angle KPL and angle JPL are a linear pair. And we know the measure of angle KPL equals 2x plus 24. The measure of angle JPL equals 4x plus 36. And it asks us what are the measures of each of these angles. So, since I know these are a linear pair, oops, wanted to use my pen. There we go. The measure of angle KPL plus the measure of angle JPL is going to equal 180 since they're supplementary. So for KPL, I can substitute in 2x plus 24. For JPL, I can substitute in 4x plus 36. And again, these equal 180 degrees because they are supplementary. So let's combine like terms. 2x and 4x is a 6x. 24 and 36 makes a 60, equals 180. So to solve this, I'm going to subtract 60 from both sides. And I get 6x equals 120. Divide both sides by 6, and I get that x equals 20. Yay! But that wasn't the question. So you have to go through and make sure you answer your question. So my question is, what is the measure of angle KPL? Well, right here, I know that x is 20. So I'm going to do 2 times 20 plus 24. 2 times 20 is 40, plus 24 is 64. Again, I'm going to come over here, and this one, this x, I'm going to make that 20. So 4 times 20 plus 36. So 80 plus 36 is 116. So now, a good way to check, we know these are supplementary. They should add up to 180. So 116 plus 64 is 180. So we know we've got the right stuff. Good job, you guys. You're awesome. Alright, vertical angles. They are, a lot of people think vertical has to mean up and down. They don't. Vertical angles just have to be across from each other. They, again, are made out of opposite rays. So if I have this right here, its opposite ray is here. And let me grab a different color. Let's go with that one. Now it's fine. If I have this right here and this right here, they are made of opposite rays as well. And vertical angles are the one that's basically made out of one yellow and one black. So, like this angle here is vertical to this angle here. They're the ones that are across from each other. So angle 1 and angle 2 are vertical angles. Key thing you almost want to look for is that they make a perfect X. Perfect X. Alright, let's see if this statement is true. Angle AFE and angle CFD are vertical angles. So let's trace those angles. AFE is here. Alright, and then let's look for angle CFD here. So CFD is there. So the question is, are they vertical? So you want to look and see, do they make an X? Do they have perfect opposite rays? So from FC, is its opposite ray FE? And it is. Ray FA goes this way. Opposite is that ray FD? It is. So yes, these are vertical angles. And it says explain. They are made from opposite rays. Awesome. Now, let's talk about some theorems. A theorem is a statement that is proven. Alright, there's your big difference between that and a postulate. A postulate is not proven. A theorem is proven. And we can prove things like there's a theorem called vertical angles are congruent. And you can prove it by using postulates, definitions, properties, and any other previously stated theorems. So that's what we're actually going to do next, is we're going to look at the vertical angles theorem and we're going to prove that it's true using postulates, theorems, definitions. Okay? Vertical angles theorem says vertical angles are congruent, which means angle 1 is congruent to angle 3 and angle 2 is congruent to 4. And I can prove that. Alright, now in a proof, what you need is you need to split your paper into 2 columns. The left column are called statements and the right column are called reasons. Alright, so you always start with your given statement, which is angle 1 and angle 3 are vertical angles. And our reason, how do we know that? It's given to us. It's plain as day. Alright, so from there, we got to try and prove that these are congruent. Well, we got to use stuff we've already learned. Is there another angle pair in here that we've already learned? Did someone say linear pair? If so, you're right. There are some linear pairs in here. We have a linear pair at angle 1 and angle 2, a linear pair with angle 2 and angle 3, a linear pair with angle 3 and angle 4, and a linear pair with angle 1 and angle 4. So, I know that all those linear pairs are supplementary. Well, I'm going to use that. I either need to go from 1 to 4 to 3, or I need to go from 1 to 2 to 3. Let's go 1 to 2 to 3. Alright, so I know that angle 1 and angle 2 are supplementary. And I know that angle 2 and angle 3 are supplementary. And I know that because of my linear pair postulate. Alright, so now, what does supplementary mean? How can that help me? Well, supplementary, we learned, means that they add up to 180. So, from there, I know that the measure of angle 1 plus the measure of angle 2 equals 180. And I know that the measure of angle 2 plus the measure of angle 3 equals 180. And that, how do I know that? How do I know that supplementary means 180? Well, that was a definition. That's your definition of supplementary angles. So next up, I got to take these two things, and figure out what to do with them. If this equals 180 and this equals 180, then does it make sense that these two guys would equal each other? Yeah? Alright, so measure of angle 1 plus the measure of angle 2 would equal the measure of angle 2 plus the measure of angle 3. Does that make sense? If they both equal 180, then they equal each other. And I know that using substitution. Now, substitution means, just like think of like sports, when you substitute things out that equal each other. If you know two things equal each other, you can take one out and replace it with something else. That's substitution. Well, look here. I've got an angle 2 on both sides. So what I'm going to do is I'm going to subtract angle 2 from both sides. And what's that going to leave me with? That's going to leave me with the measure of angle 1 equaling the measure of angle 3. Well, how do I know that I can subtract 2 from both sides? You learned that in Algebra 1. It's called your subtraction property. It means you can subtract from both sides and you're still equal. It works. Alright, so I've got the measure of angle 1 equals the measure of angle 3. So the last thing I got to do, I got to make sure my statement looks exactly like this one. So I need to say that angle 1 is congruent to angle 3. And how do I know that? That's what congruent means. Congruent means they have equal measures. So this is my definition of congruent angles. Now, I know that may have seemed really confusing, and we'll be doing more of these. So hopefully parts of it at least made sense to you. And like I said, we'll be doing more of these the rest of the year, so don't get stressed out if this didn't click. We'll do more.